So those were precipitation reactions. Now we're going to talk about acid-base and gas evolution reactions. These are two other types or classes of reactions. And we can think about the same analogy of people mingling at a party and swapping ions when we look at these. So an acid-base reaction, as you might suspect, is a reaction between an acid and a base. It's also called a neutralization reaction because the acid and the base neutralize each other. And when they do that, they're going to produce water and generally a salt, such as sodium chloride. Salt is a generic word for an ionic compound. So table salt is sodium chloride, but salt in general could be all kinds of things. A gas evolution reaction, as the name suggests, evolves gas. So a gas is given off, and we often see that as bubbling or fizzing. You can see the gas bubbles coming out. So to talk about acid-base reactions, we have to define acids a little more closely. So there's multiple definitions of acids. The Arrhenius definition is the one that we've been working with, a substance that produces hydrogen ions in aqueous solution. So we've looked at HCl before. You put that in water, you get hydrogen ions and chloride ions. That's an acid. Actually, though, the hydrogen ion, my pointer is moving without me. I hate it when it does that. This hydrogen ion actually doesn't float around by itself in solution. Let's think about a hydrogen atom. How many protons does it have? 1. How many electrons does it have? 1. So when it becomes a hydrogen ion, H+, it loses the only electron it has. What's left? It's a proton. A hydrogen ion is a bare naked proton. Teeny, teeny, tiny thing. Okay? So in chemistry land, I think of hydrogen ions as being like newborn babies. They don't go out by themselves, right? You don't see newborn babies waiting for a bus stop. You don't. They're always being carried by someone. So water is like the parent or the babysitter that carries that little tiny hydrogen ion. So the hydrogen ions are not actually out by themselves in the solution. They actually piggyback onto a water molecule. So here we have the hydrogen ion combining with a water molecule to form a new ion. This ion is called the hydronium ion. Now, most chemists use hydrogen ion and hydronium ion interchangeably. And we do that because writing equations is much simpler if you just use the H+. But the truth is that H+ doesn't actually exist by itself. That hydrogen ion can be with the chloride ion that it came with, or it can be on the water molecule, but it's not just out by itself. So that's the Arrhenius definition of an acid. A base is a substance that produces hydroxide ions in aqueous solution. So something like sodium hydroxide. This is a soluble ionic compound. Sodium compounds are soluble. When this dissolves, it forms sodium ions and it forms hydroxide ions. Bases such as ammonia. Ammonia is a base, but it doesn't have OH in it. It still forms hydroxide ions in solution by pulling the hydrogen off of a water molecule. Polyprotic acids, poly meaning many, protic referring to proton, the hydrogen ion. They contain more than one ionizable proton or hydrogen, and those can be released separately. So sulfuric acid, when we look at the formula, H2SO4, this has 2 ionizable hydrogens. And they actually do come off one at a time. So we can get the H2SO4 aqueous, and that can dissociate into hydrogen ions, which would be riding piggyback on a water molecule, plus a hydrogen sulfate ion. This is a strong acid. This hydrogen ion comes off completely. There's none of this left. This hydrogen sulfate ion has a hydrogen ion that can also come off. This is a weak acid. It only dissociates a little bit. So we tend to use the double-headed arrow to mean that both of these things are present, the hydrogen ion, aqueous, and sulfate ion. But the important thing that you need to get out of that is acids can have more than one hydrogen ion that will come off. So sulfuric acid is a common diprotic acid. Phosphoric acid, H3PO4, is a common triprotic acid. It has 3 protons that can come off. And with bases, we don't have a special name for them, but some bases produce more than 1 mole of hydroxide. So if we look at like calcium hydroxide, that's a base. And when that dissolves in water, it's only slightly soluble. It's not as soluble as like sodium. But the part that does dissolve will separate into ions, and you'll get calcium, and you'll have 2 hydroxide ions. And so that can happen with calcium, barium, and strontium hydroxides. So we recognize acids because they start with an H, and we can recognize bases because it's going to be some metal with hydroxide. There are other ones, but the metal hydroxides are all bases. Any questions?